Good afternoon, ladies and gentlemen. Michael Clark, OPC Foundation, North America. It's a privilege to welcome you. Many of you know me, sorry, no refunds. I'm really glad to welcome you, though, to our session this afternoon. We've got a packed agenda. I'd like to stay on time as best we can. In our agenda today, we're going to cover the following items. We're going to have a guest from Procter & Gamble, the production of architecture overhaul. And this is Jeff Kent from Procter & Gamble. Then we'll have the OPC Foundation report from our president, Stefan Hoppe, who is in attendance here. The Cloud Library and the Cloud Federation will also be part of his topics. We'll turn a bit of time over to Peter Lutz, who's the director of the FLC initiative. FLC stands for Field Level Communication. And that's the auspices under which the OPC UA FX, or Field Exchange, is being managed. In that, at that point, then we'll go into collaborations. I'll give a few announcements at that point, and then we'll turn some time over to John Dyke from SESME. That's the Smart Manufacturing Institute here in the United States, and a announcement on the Digital Twin Consortium. And our friend Dan Isaacs will come on stage and give a few comments as well. After that, if we've got time, we'd like to open it to the floor for some Q&A.
So for some of you, I spoke yesterday about some of the important product supply and operational intelligence initiatives that we have. So I'm going to revisit the overall premise of what we're working on, but then really tie it to an emerging relationship they're having with OPC Foundation and some of the critical initiatives that really can make this possible. So it's always important to start with, what are we talking about before we get into the foundational reference architectures and communication. So what I spoke to yesterday was Procter & Gamble's committed to introducing AI and machine learning models to the thousands across our operations with a particular focus at the equipment level, and then having the equipment collaborate across key work systems, whether it be quality assurance, maintenance, HS&E, material utilization, et cetera, et cetera. So what I'm going to describe is how we not only invest in the cloud and on-premise installations, but also what we're doing at the control edge, not just the OT edge. So before we get into what that looks like in the value and the architectures, we got to start with what are we solving, right? So I spoke to yesterday, and I'll do it briefly. There's some 4 fundamental things that we see in our manufacturing sites that need to be addressed. Number 1, and this is really paramount to our relationship with OPC and OPC UA, is we need to get the data out, we need to get it at the right time series, and it's got to be contextualized. So anywhere in the architecture, we need to be able to access that repeatably and be able to scale that over and over again against different operations. Once we've done that, this is where the subject matter experts and the data scientists have to figure out how to work together. It's not so easy. Once you have the data, you have to be able to explore the data, perform the different data science exploration techniques, and come up with an algorithm that you can depend a 24/7 operation on. But then once you have that algorithm, usually this is done between engineering and data science and manufacturing, this algorithm has to be put into a 24/7 operation. So how would you operationalize a model and have it run, in this case, on the control edge, with the resources that work in manufacturing, not just IT. And then finally, once it's running, I have to run it for the next 10 years. And so what we all should recognize with this data, with the data model, with the model that's running, it's going to drift, it's going to adjust. So what is the DevOps and MLOps environment that will support the integrity of machine learning times the thousands across 120 sites against 10 to 20 different workflows with the same confidence that we run traditional controls and automation? So we introduced a few things to try to simplify this. I've been in my job, and I didn't describe my job, but I'm the vice president of smart platforms in corporate engineering in P&G. And I've been in the job 5 years, right? So we talked about how long does it take to do a digital transformation? Well, it takes some time, and it takes some failures, and it takes some learning. But in this case, about 2 years ago, a nice healthy discussion between my leadership and I was, this has to get simpler. This has to get more repeatable. We have to create a menu of products and services they can buy and apply with confidence. My first answer was, it's not that simple. I don't think it can be that simple. Well, the reality is, over the last few years, we've been committed to making it that simple and finding industry partners, government, academic, foundation partners to help us make that simple. So this slide describes where we're at. We've created a technology stack with the industrial automation partners to be able to deliver GPUs, IPCs in a very consistent manner to perform DevOps on it in the control edge. And then we've introduced WISE as a end-to-end lifecycle of both support of those assets, but the machine learning lifecycle more specifically against the use cases that we need. But underlying that is what I'll get into, is there needs to be this network communications model that go from sensors to controllers to the OT to the cloud, and then all of the different bi-directional nature of all that information. And we've, as I get to the punchline, we see no better way than to perform this through OPC Foundation's introduction of OPC UA in its broad different forms. So what we're trying to achieve with this is, machine learning AI is a nice buzzword. It's been achieved by really brilliant people in pilots, in demonstrations, with very great partners across the industry, but it's been very difficult to scale. There was a percentage given by Gartner just a few years ago that only 10 to 20% of industrial IoT or machine learning solutions scale across the company. It's a pretty scary number, and we're trying to crack that by getting this done in about a tenth the time, 10% of the cost that we were achieving, and with much higher confidence. So that's the objective of what we're doing. And as I get to the OPC connection, it has to still be fundamentally sound on the communication and data. So I'll give you a general kind of nice conceptual drawing of what we're trying to achieve. So you can imagine that Procter & Gamble, we have wide variety of OEM equipment across all of our different business units. Some well-managed, some managed through the OEM, some written by Procter & Gamble controls engineers. Well, regardless of the maturity of those production assets, they're gonna have to be connected and be able to harvest the right data model to serve our machine learning objectives. So we've chosen, as I said, to introduce a control edge device that can talk to any number of our control vendor platforms, do it in a very consistent way, and do it through standard communication protocols like OPC UA. Once that information is in the on-premise VMs and servers, it also starts to permeate up into the cloud and also from VM to VM. So we see this need to have this information flowing across these different parts of the Purdue model. And what we recognize is that a whole machine learning lifecycle that will support that from the equipment all the way up into the on-premise, into the cloud, and then back down all the way to the control edge. Because our premises, many of the algorithms that run machine learning in our core work processes don't and will not run in the cloud. They will actually run down next to the control system, particularly for our things that are gonna really run adaptive control. But we have the ability to run these machine learning algorithms in the cloud, on the prem, or on our control edge device. But inevitably, it still has to be a nice flow of information in a consistent manner. We've also introduced this concept of WISE, which is a codified approach to machine learning that allows for everyone in Procter & Gamble, particularly in manufacturing, to understand where you are in this phase. And it's really not a linear process. This should be a cycle, but it's hard to write this as a cycle. But you see that on the bottom, the different hardware assets and infrastructure and where it plays in this cycle, how OPC UA is the avenue which the information flows, and then the different stages, I would call them, in that cycle of machine learning, all the way to maintaining the model in operations indefinitely. So for us, WISE is not only a conceptual model, it's a model of services that we're going to introduce through Procter & Gamble and our partners, and it's going to make sure that everyone performs with integrity machine learning for manufacturing. So we bring it home here. There's a lot to be done in those conceptual slides, right? Those are nice and pretty and fancy and exciting, but in the end, we got to build all the layers of the cake, right? The machine learning algorithm, the UX that runs on top of that. To me, I always call it the frosting. Well, we got to get into making the cake, and we got to get the right ingredients. And we find that some of the initiatives that are going on with OPC are vital to us with the right ingredients and the right cake. So, John Dyke's in the audience here. Him and I have had a nice, healthy conversation about the Purdue model has been really good to serve us well for many, many decades to play our position on the field, whether you're a sensor vendor or a control vendor or a server or level 2 provider. Well, in the end, we've been respecting that for too long. What we really need to do is start to blur some of the levels of the Purdue model so this can be a much more broadly communicative architecture, much more open for everyone to participate. Now, we'll still have to do the best job as a sensor provider. You have to do the best job as a automation provider. You have to do the best job as a level 2 hyperscaler and others. But in the end, if we don't introduce this more agnostic network of things rather than what we see in the Purdue model, I don't think we can deliver Industry 4.0 or the power of intelligence. Additionally, we're all introducing cloud, right? There's our own internal clouds, there's the open cloud, there's our proprietary clouds, there's the field device to cloud. I think we also need to pay attention to what this is going to look like, particularly for supply networks, right? I mean, I can talk all day about a manufacturing node, but those manufacturing nodes are now going to be complemented by very important distribution nodes, customization nodes for Procter & Gamble. So as we build this intelligent architecture, multiple nodes, multiple sites, multiple clouds, and that being able to flow where it needs to flow for the algorithms is going to be vital. Again, these initiatives from field to cloud or cloud to cloud are going to be very important, and OPC is at the forefront of defining what that should be. And then finally, I'm a controls guy, so I'm in love with the field, right? I love sensors, I love vision systems, I love advanced sensors, and they have to be able to effectively flow, right? To the controller, not to the controller, and the world that we're building is certainly around that. So I'll give you an example for us. I was just talking about our sustainability efforts, and one of the exciting new projects for energy and water analytics is to harvest energy and water sensor information through LoRaWAN. And the LoRaWAN is going to be communicating to a smart box, and then it's going to be provided to the cloud. So those are some initial examples where we're not going to respect the Purdue model. Why should we? We're not going to take the complexity of sending information through different layers when it really needs to go to where it's going to play and do so with the highest integrity, cybersecurity, and common standards. And we want to roll that out to all 120 factories, hopefully within a year. You think we're going to do that if everybody's doing that a different way without the common protocols? No. So this just gets us not only very, very proven approaches, but gets us speed to implementation and a common language. And so we're all seeking to have a common language, right, between IT and OT. Well, I see no better way than what OPC Foundation is offering Procter & Gamble and all of us with these initiatives. So if I close, because I want to make sure we have time for everybody else. As I said, I'm a controls engineer who is tolerating the term OT, okay? Because I think OT is very generic for what we accomplish in controls. And we're committed in Procter & Gamble to make sure that the controls assets are respected and they're part of an intelligence movement. I also bring up this slide, and sometimes I write the independence movement, because the control system will perform intelligence with or without on-prem and cloud installations. But I'm committed to making sure that we can do both. So in our less mature sites, the control edge is going to be served, and we're going to do intelligence whether we have all the rest of the infrastructure or not. And when we have the chance to be thoughtful and mature with OPC and other solutions, we'll fulfill the whole reference architecture.
Ladies and gentlemen, I just wanted, before we let Jeff escape, I'd like to share with you a thought or two on how Jeff and I met. We met in San Diego last year at the Industry of Things World USA. And it was remarkable. I was there with you and Kathy St. Clair, another rock star controls engineer at Procter & Gamble. And we started to talk about the synergies between what the OPC Foundation does and some of the work that Jeff and Kathy and all of his teams are doing at Procter & Gamble. Immediately, we started to say, this is good, this is helpful. So one of the things I'd like to announce is that Procter & Gamble is our 900th member. We're very grateful to welcome them into our organization. Before we dismiss Jeff from the stage, I'd like to shake his hand. We're going to have Peter give us a little time for a photograph here. And if we could, we'd invite Stefan to come up on stage and just be with us. We'll do the three-man handshake here.
What am I signing up for you?
Well, it's not a blood oath or anything.
Thank you so much for your commitment, Jeff.
You're welcome.
Should we go more to the front here?
Yeah, we could do that.
But don't fall.
Yeah. Thank you, everyone. Now that
Thank you so
Stefan's on stage, we'll turn some time over to him for the update.
Thank you so much. And again, Jeff, thank for your commitment. Having Procter & Gamble as a member in the OPC Foundation is an honor for us, right? I'd like to share some, I have to look here, okay. Some news on the OPC Foundation. Very quickly, membership, OPC in different initiatives. Also nice key messages from the AGEMA, which I like to transport here over the ocean. And also some news on other areas. First of all, to give you one slide on the OPC Foundation to remind you that the O from OPC Foundation stands for our openness. And this means that we are not only open for new members, but we really live and breathe that once a specification is released, it is public available for everybody in the world free of charge. And also we have open source offerings as sample code on GitHub where everybody can download and participate of. But also there's a huge ecosystem with toolkits and other trainers. And if you go and go with a quick solution with a toolkit, you can even go to the OPC lab without being a paying member of the OPC Foundation. For sure, you have to pay for the test engineer, but you don't have to be a paying member of the OPC Foundation. And last but not least, I'm really proud that we have an IPR policy where members not only protect themselves, we are also protecting integrators and end users. This is not what everybody is offering. Overall, what is the vision? We like to move standardized information independent from domains, independent from infrastructure, operating system, and so on, in a secure way, exchange them across all different layers, from the field to the cloud, even bypassing layers, for horizontal and vertical data information exchange. We are over 900 members now, and you see the number of board members here. Overall, we believe that this is the world's largest ecosystem for industrial interoperability. There's nothing else, there's no larger ecosystem in the world. And we not only have big end users like Procter & Gamble, Volkswagen, Samsung, Foxconn, we also have the who is who of the OT world and the small IT companies like Amazon Web Service, Google, IBM, Microsoft, SAP, and others. So we really bring together the IT and the OT world, and we believe we will continuously growing here. Jeff already had this slide, and so I don't have to repeat it any longer, but I can't stop repeating that OPCUA is not a protocol. Instead, it's much more. This is the intent of the slide. It's all about agreeing on standardized information. This is where we partner with other associations and bring domain expert to a table to first agree on the semantic. At this first step, it has nothing to do with OPCUA technology. But the OPCUA technology, the framework, allows to exchange that standardized information across different protocols in the different layers from sensor to cloud and back. Because there is not the one single protocol fulfilling all requirements on field level on cloud. So you need to address different transport layers. Security is baked in by design. We have been reviewed by multiple governments and we should not make a public statement further on here. Right, okay. To remind everybody, we are really proud that we have been selected as the core communication backbone in multiple initiatives. It is, first of all, the Open Process Automation Forum, where we are proud partners. Don, I see you here, made a clear statement also. We appreciate all the collaboration with the OPAF group. And for me, it was also really a key meeting when we came together last September, I think, in Berlin. And it was really a spirit where people from different organizations and associations sit together, listen to each other, explaining to each other their expertise, why they believe this is the best way. But mostly they were listening to each other. That was super high level experts coming together. I was just a proud partner and invited everybody for a good dinner. But this is the way we love to cooperate, bringing people together and cooperating. So we are looking forward to continue this collaboration. But we also have been elected as a communication backbone, the channel for the Namur Open Architecture, what they call the communication diode, which is a one-way communication from the field out to the operational and monitoring area. And so OPCUA is the exclusive communication channel there. And last but not least, the MTP solution is also where they separated the modeling layer from the communication layer, and at least status today, OPCUA has been selected as the first communication layer, and that makes us proud, obviously. I announced to repeat a statement what ABB, the company ABB, a leader, made at the OPC Foundation press conference during the ACHEMA trade show. And it's 3 pictures. It's a little bit small, but I can navigate you through these 3 pictures. On the left upper picture, you see that you have Profinet as a field bus status today, a super established field bus solution for the cyclic data communication. But you have OPCUA on the north port to communicate vertically up into the IT world. But ABB is positioning this that in a intermediate step, OPCUA is growing down into devices. They believe there will become a lot of hybrid products running 2 or multiple field bus communication patterns in parallel. So they definitely see that the OPCUA FX technology is growing down into the field. And on their long term, they believe that OPCUA is taking over completely as a logical solution the devices. The reason is, if you compare multiple solutions with each other, it is only the OPCUA technology being able to do the field communication in future with OPCFX. Peter will talk about that. But OPCUA is the only technology scaling up to the cloud, plus having integrated IT security. Yes, we also run safety, and Peter talks about that. At the ACHEMA, we also showcased that being a member of the OPC Foundation is helpfully for, well, getting early insights, but also making best use of the networking inside the OPC Foundation. So for example, here Microsoft helped the company Samsung within half a day installing IT Docker technology, including OPCUA, into their devices. And so their devices have been connected on OPCUA technology directly to Microsoft Azure Cloud within half a day. It was really a ramp start. And so we could show that easily at the show. In the next block, I like to talk about our cloud initiative before Peter is taking over for the field initiative. And this cloud initiative has multiple topics: cloud library, cloud federation, and edge to cloud. And you see here where all these bubbles are. And I'm starting talking with the cloud library. This is at the end. I think I have stolen a slide from you, John, but it fits more better into this range here. This is a collaboration, what we did with our friends from SESME, John Dyke will later on a speaker here. The idea of the cloud library is there should be somewhere in the world open, available with IT access, cloud access, the library listing all information models, OPCUA information models. So once you order, let's say, a robot, you can directly download the information model from a robot. You can start working on your IT routines, on your dashboards and so on. And when the robot really reach your destination, you are prepared already and you just connect them and the robot is obviously fulfilling the information model which is the international standard. So this is making the work much more efficient, work in parallel, work on a standardized, agreed level. And so this repository is kind of a library where you can navigate. Is there something for a robot? Is there something for a coffee machine? Yes, don't do that, don't start, it's available. And multiple more than 85 information models are available. You can upload new ones, you can search and so on. There are also big IT companies like Amazon, Google, and Microsoft having been part of that group and that initiative, and we are really proud that we cooperated with SESME here in this kind of joint working group. The Industrial Cloud Federation has a different topic. It is really use case driven from manufacturer point of view, because obviously, every supplier is delivering components to a factory floor, and every supplier wants to have data back to learn on his own product, to optimize the product. But this is not what normally the manufacturer wants. He wants to control data, and first he wants to have all data in his own cloud system. On the right side, you see the scenario where all data from the factory plant goes first to the manufacturer cloud, and then there is an agreement on which kind of data are forwarded to other supplier clouds. And obviously, we are dealing with the same challenge on how do different systems connect with each other. In this case, cloud systems, how do they communicate to each other? If we have standardized information on the shop floor, why should we create new information models on the cloud, instead reuse existing standardized information? So how can we forward just the cloud, the messages bubbling up from the field via OPCUA over MQTT and just forward them? And this is a result where they made proposals, and this working group has sent a request to the OPCUA core team, to the architecture team, saying, hey, we need this functionality, please bring that into the core mechanism so we all can benefit from this. This is where you can see how new groups and collaboration groups are influencing the OPCUA technology and make it richer and support more use cases. Talking about how does information bubble up from machines, and this is really the situation what I hear a lot today. Also, by the way, here on this conference, MQTT is the solution, and hey, Stefan, what is the benefit of OPCUA compared to MQTT? And I have to take first a deep breath and then start my explanation. Hey, we love MQTT, but MQTT is just a transport channel. It does not provide you interoperability. Even if everybody is talking MQTT, this means nothing. Again, we love MQTT and we use it, but here this picture says if two controller companies are pushing data, even the same values and the same variable names via MQTT, this does not mean you have interoperability, because the schema itself, the binding, the JSON binding might be a little bit different. And so the receiver always need to do some formatting and write some import routines. This is not efficient. Instead, we believe it should be OPCUA over MQTT, and this has been confirmed to be supported by all major cloud vendors. This made us super proud, and Here on the right side, you see the press release which has been published in February last year, where all major IT companies committed to support OPC over MQTT. The spec of the OPC Foundation has been published in February 2018 already. So it's long time available. Nobody can say I was not aware of that. And it's more than just pushing data in a JSON format. We also can push data in a binary format because we thought a little bit broader what are the use cases and how to secure messages and encrypt a message to be also super secure inside a broker and from the broker to the receiver. So we believe that having large experts in the room, a large number of experts in the room exactly helps to cover all kinds of use cases and then make a concept out of that. At that year, 2021, we only had 2 OT companies pushing OPC over MQTT directly out of the controller. At that time, to Microsoft Azure. Here it is Beckhoff and Siemens. But just a year later, we have been super excited that also Amazon Web Service made a live showcase at the SPS show in November with their own partner pod at the Amazon Web Service booth, showing they are able to receive OPC over MQTT messages. And we have been second super excited that meanwhile the number of supporting companies grow up to 25, including all major automation companies. You see logos here from Beckhoff, Siemens, Phoenix Contact, Vago, and multiple more. And this list will grow dramatically more and more. So we have a test bed already, which is running 365 days. If you like to participate in that test bed, to push your information, OPC over MQTT, into that system, being displayed on 2 different dashboards, on Microsoft Azure and on Amazon Web Service, please contact us, and we like to integrate you into that test bed. And second, you also see this demo wall at the OPC Foundation booth here. If you leave this door, just turn right 2 meters and you see the demo, and we can give you live demonstrations. But again, what we are super excited, we have one solution, one ISC standard, which allows multi-cloud solutions without being running in a vendor lock-in for specific clouds. You do not have to add different routines on different clouds. I'm not repeating this again, but you received the slides anyway, but again, be careful, MQTT is not MQTT, and MQTT is not interoperability. That's a short message. It's a transport pipe. You have to define the content inside. And the rest is exactly what I talked about. Okay, with this, I think I'm allowed to hand over. Then I hand over to you, Peter, for the field.
I would like to now give you an update on the status of our field level communications initiative and talk also a little bit about the further roadmap. So first of all, starting with a slide that I presented last November at the SPS show in Nuremberg, because we celebrated 4 years FLC initiative. As we were establishing the FLC in November 2018, you see here the picture taken from the remarkable press conference, having commitments from all the big players in automation supporting this initiative, bringing OPC UA to the field level. So you see the logos of those companies that are today member in our steering committee. This steering committee is defining the requirements and the use cases, and also defining the roadmap according to which we are developing our specifications. Before I forget, the happy birthday is today also for a special person here in the room. So let's say happy birthday to Mike. And
Happy birthday!
And we're looking forward to the big party this evening that you organized for us. All right, so maybe a quick introduction what field level means and what aspects we have to consider when looking at the solution approach. When we want to bring OPC-UA to the field level, we have to look into different aspects and use cases. And you see in this yellow bubble some of the terms we are dealing with. So it's about functional safety, it's about adding determinism, it's about looking into all the different device types for the different applications in factory as well as in process industry. So it's about motion control, remote IOs, field instruments, and certainly other devices as well. And because this overall is somehow quite complex task, also because we have all these field buses today established, we divided the work into two parts. So we said, first, let's focus on the controller-to-controller use case, which is listed here with the number 5. And then in a second step, bring these concepts down to the real field level, to all the field devices for the controller to device, also including device to device. And you have heard about the UAFX. So FX standing for field exchange. This is, let's say, the term we are using for the extensions we do for the OPC-UA framework. But it is OPC-UA, it's nothing new. We are just adding things to the OPC-UA framework. A big milestone we reached November last year. So after 4 years, we were really glad and also proud finally to release our first specifications. So 4 years seems to be a long time, but you have to consider we have all the big automation players together in working groups. They, for the first time, work together with each other. So maybe we lost at least the first year for getting the same language, getting understanding each other, and taking also out some of the non-technical side effects when you bring such companies together. And we had COVID suddenly. So the 4 years are actually, I think, not too bad. Even we wanted to do this faster. So we are really proud to have these specs out. You see it's 4 parts. You see the cover pages with the numbers 80, 81, 82, 84. As Don mentioned with the OPAS standards yesterday, these are now robust specifications. So they have undergone different iterations internally. We did extensive prototyping to really make sure what we are publishing can be also used for conformance testing. So this is what we are currently preparing. I put here Q3 this year, so we expect 6 to 9 months after the spec is out also to have conformance testing in place. So the good thing is vendors can now create their commercial offers, and we have end users starting pilot projects with first prototypes. Another important element, I mentioned functional safety at the beginning, is a specification that was recently published already as, let's say, the 3rd release. Work started even before we started with our FLC initiative. This is why this is already has been published quite early. The first release was July 2020 already. And this is supporting client server. It's also supporting pub/sub. And we just did a maintenance update with the latest release in November 2022. To give you a little background why safety is so important, with OPC-UA safety, we are adding a safety layer on top of OPC-UA to enable fail-safe applications running OPC-UA. So this is an additional layer detecting any possible errors that can occur. And we are able to support even applications up to safety integrity level 4. The really unique characteristic of OPC-UA safety that it can run, as Stefan highlighted also, over different transport protocols and any kind of physical layer. It can be tunneled through any transport you can think of. And this is so different than the safety protocols we have today in the field, because they are typically bound to a dedicated field bus. With OPC UA safety, we really have a universal solution out, which is getting also big support from all the manufacturers. You see here some activities related to the spec. So it's not only that we have the spec out, we are also having started 2 development projects. One to implement a safety test tool that we can use for conformance testing and companies can use for in-house testing. And in addition, the development of safety stack, which can be used by companies also in their commercial offers. So far, 32 companies, let's say, paying and contributing to this development. And this will certainly accelerate the adoption of OPC UA safety. Okay, I also have one photo of our demo that is outside, maybe already dismantled, I'm not sure. Hopefully you had the chance to look at this. This is actually a demo, the first demo we did on UAFX multi-vendor back in November 2021. And you see here overall 17 controllers, actually 16 in hardware, 1 in software, all connected to a common network infrastructure, all connected to a common dashboard. And we are using, on the one hand side, client server to do diagnosis monitoring, to read out asset information. But the significant point here is that we are using this demo also to highlight the new use cases for UAFX, and this is controller to controller. And I have here one slide to explain a little bit the use case. We took the application scenario of a bottling line. You see here consisting of 4 elements, so a washer, a filler, a capper, and a labeler. And the controllers are, so to say, assigned to these tasks in this production line. And on the left-hand side, you see the 2 connection managers. So they are, so to say, orchestrating all the connections between these controllers. And by using these connection managers, you then can set up flexible connections between these controllers using publish subscribe, so it's real-time capable. You can exchange safety critical data, and this all cyclic. And as I said, this is the basis also for our control to device extensions we are working on. This brings me to what is coming up, what is the further roadmap. And you see here in the green frame, now the use cases we are now intensively working on. So we have done the spec on the controller to controller. Certainly we will do maintenance on that, but now the new work is now related to C2D, what we name this, and including D2D. We have had a kickoff, I saw this slide already before, in July last year, also handing over the requirements to our technical teams. We put the working group structure in place. We will actually launch 2 new working groups just maybe 2-3 months from now, working on instrumentation and working on I/O. And you see the different work items listed here. Very important is the parameterization. So controllers parameterizing the field devices, providing also access to device tools and engineering tools. We will work on extended or enhanced diagnosis, and then adding all the information models and device behaviors for motion devices, I/O devices, field instruments. So this is now the task for the next few years. So I'm always asked how long it will take. So this is a difficult question, but my message is typically in 2 years we have a spec out, and some complain and some say we are much faster than this. So the 2 years maybe are not too bad from an estimation. All right, with that, I think I'm at the end of my part, and I hand back to
me.
you, Stefan.
Thank you, Peter. And again, congrats from my side. It's absolutely a great job what you did because, well, bringing that automation giants to one table, to one room and agree on something is definitely not that easy. So congrats again. I'm not moderating in the complete next part, but I want to just make one announcement here about our strategy extension, and this is in two directions. The OPC Foundation, driven by member activities, will grow on the one hand from information models, what we have in the area of manufacturing and process automation, more and more into the energy-related topics. This is a principal announcement here, and Mike will dive into more details in a second. The other direction is that we are more and more addressing also IT-related topics, because a lot of people outside on the market believe OPC is just the last mile to a physical asset which I can touch, and it's the last protocol mile, which I hope I gave some information. It's not a protocol, and we are scaling to cloud already. But we also learned that, hey, there's even much more coming, not only moving data to the cloud. If you look, if you have looked and followed, there are multiple more concepts, for example, on data spaces. Also, I had to learn on what is a data space. I don't have, by the way, I don't have a specific slide on that, but a data space is something where you share data with others, and you are still the owner of the data. Anytime you can recall the data, and then the data are no longer available for others. They can't make a copy of that. And this is a concept which is super interesting. And for us, we were surprised and we were honored that meanwhile, two companies in the world have already made an OPC data connector to these data spaces. One is maybe coming from the research area, the Fraunhofer Institute, Germany, okay. But the other one was the Japanese telecommunication company, NTT. And I was participating at Data Space Congress end last year, and you can maybe think about my surprise going through the exhibition where I'm not really deep familiar with, and I'm opening a brochure from NTT and seeing, oh, we are trusting on OPC as our data connector. I said, wow, cool. So we should precisely look at this and support companies, share more information to help them. The asset administration shell concept is a little bit different, and honestly, I truly believe that all the big big enterprise companies have enough resources to send their experts in all these different initiatives. But I also believe that small and medium-sized companies are a little bit lost on all these new concepts and also changing concepts. So the asset administration shell is not a digital twin. It's a different concept. It is to collect data on the complete life cycle of a product. When it's designed, the cut paintings and so on, the drawings, and save that. So you can more think about a zip file where you put in different information like a Word document and a PowerPoint and something else, and you zip it and you provide it to somebody. And this asset administration shell has also a REST API to get data out and in. That's all fine. But the big question is also, how do you connect or collect data from the operational product phase, where mainly OPC is dominant, into that asset administration shell. And right now, the OPC Foundation is working with other associations on a white paper on the big picture interoperability to exactly navigate people through this, let's say, jungle of new up-bubbling initiatives and standards and so on. So we are carefully monitoring this. The metaverse is also something where you might think about, okay, what is this now? But here also we have started a new initiative, and it is, and this is something where I'm not reading it line by line, but remember that the OPC Foundation has a board of directors with a good mix of OT and IT companies, and this has been a proposal by our IT companies. Hey, this is an upcoming topic, we should be prepared in time, and so we are today just making a teaser that we have started this as an internal working group, and you see here that the board members, and I see that company Schneider is missing, so please add that. I have to fix that text. Is also part of this. Right now, board companies are talking about the focus, what is the direction, they're exchanging information about their understanding of the metaverse. You have listened here to a presentation from company Siemens on this. And so we have an active working group already. Once we are more clear about our direction and so on, we will open the group and make an international call for participation. I like to make a teaser that it definitely makes sense to join the OPC Foundation booth at the Hanover Trade Show, because you will see a demo there, right? With this, I like to hand over to Mike to navigate through the rest of the information. I did not want to mention all the other collaboration partners. I do not want to steal your content, but this is obviously upcoming.
Thank you. Appreciate that. So before I go back into the next part, let me go back to this slide just for a minute, because I will be speaking in a moment about the carbon capture initiative, but there is an announcement, and I'm going to give the floor to Dan Isaacs from the Digital Twin Consortium to make this announcement about the MOU between the OPC Foundation and the DTC. So let me just quickly jump into this. We have several initiatives that we announced on Monday at the press conference. So those of you who are representing the press, you can go to sleep for about 2 seconds. Just kidding. This is actually one of the things we talked about. So you'll see here that the OPC Foundation, SESME, which is the Smart Manufacturing Initiative here in the US, and the VDMA, which is the European Mechanical Engineering Association. We have representation here this week from them as well. We all agreed on a what's called a MOCA. Now, forgive me, you're going to hear guys like Stefan and myself and anybody that's working for the OPC Foundation use the term MOCA or BOCA quite liberally. Let me just give you a quick hitchhiker's guide to what that means. MOCA stands for Multi-Organizational Collaboration Agreement. BOCA would be the bilateral organizational collaboration agreement. MOCA, because we've got multi-companies here, this was signed by these groups in order to help with solar PV operations and maintenance. This then has a deliverable. So a charter is created, the charter states what the objective is, the deliverable will become an OPC UA companion specification. And that's what this charter is all about. This is all part of a larger initiative that the OPC Foundation has been engaged in for a while. Some of you may recall last year there was an initiative kicked off about the energy consumption management, and that was another charter that was put forward. You're going to see additional announcements around this in the future, but this particular one deals with solar and photovoltaic. There was one announced on laser systems. This one was between the OPC Foundation and VDMA. And this deals with the laser systems consisting of companies that are looking at the communication of laser systems from high-level systems and devices in their respective processes. The last one that I'm going to announce is the carbon capture and storage. This one is, again, between OPC, SESME, and VDMA. This one particularly was founded by Predictor, Equinor, Beckhoff, and Microsoft. So these were the founding members. Naturally, that started to capture attention because they have something that they're working on. And so as a result, they're like, why don't we just turn this into a companion spec so that it lives on in perpetuity? This is good. So their deliverables, they're looking at everything from capture equipment, compression, storage, loading and unloading. This is the jetties in particular, transport, injection, and metering. Now there is something that's a bit of a note here. In this particular carbon capture and storage MOCA, or this companion specification, there is an active project that's underway. It's called Northern Lights, and this is a joint venture between Shell, Equinor, and who's the third one? Total. These three companies are working on Northern Lights together, and so they're going to work specifically focusing on storage plants for liquefied carbon. That's not to say that these other topics are not front and center in their minds. It's just that they're going to work on these ones first. All right. Allow me to turn the floor over now to Mr. John Dyke. He is the CEO of SESME. SESME stands for Clean Energy, Smart Manufacturing Innovation Institute, and John's going to take it from here. When John's finished, I'll have him turn the floor to Dan, and then as soon as Dan's completed, we'll go into a Q&A session.
Well, good. I thought it might be me between you and a beverage, so I'll hand that privilege
Dan.
off to Dan. Yeah. Well, so I'm going to, for better or for worse, I'm going to change the sort of level of the conversation briefly to sort of abstract us to about 50,000 feet for a moment, just to talk about how, from our perspective as the Smart Manufacturing Institute, excuse me, we view the importance, the vital importance of the work that the OPC Foundation is doing around interoperability, and how SESME is, as a federally funded institute here in the US, is trying to bring that, leverage those important ideas to bring interoperability to the masses. So we're kind of a unicorn in that we're industry experts that have been funded by the federal government to accelerate the democratization of smart manufacturing. We've received $140 million in funds. We deploy that by convening an ecosystem. So we're a consortia, manufacturers, systems integrators, technology providers, machine builders, and the knowledge or academic ecosystem to think important thoughts about how we can accelerate the adoption at scale of smart manufacturing in this country, to create a more competitive manufacturing environment, and then to invest in those things, to actually create, develop, advance or accelerate the investment in vital technologies and knowledge that we think will serve our mandate to cut the cost and complexity of smart manufacturing deployments in half over 5 years. And so from our perspective, it's in the analysis that we've done with the sort of smart people that we are convening to address these vital issues, we've recognized that there's been 30 or 40 years of major manufacturing systems innovation in this country and around the world. That, in fact, innovation has been the hallmark of manufacturing of manufacturing here in the U.S. And so, it's from our perspective, these great, virtually every technology provider and consulting organization has great sort of frameworks through which they can communicate the value of these types of things, and of course that's important. But the reality is we've been doing this for 40 years. There's really nothing new in that McKinsey framework for value creation for the fourth industrial revolution that we haven't been doing for 40 years, literally. That 40 years, the past 40 years of innovation looks like this. Every manufacturer I've ever talked to has some version of this. This is an actual manufacturing organization that you would all recognize. This is their sanctioned manufacturing IT systems landscape. Every one of these boxes is deployed in about 68 plants. Each one has its own information model, its own user experience, its own set of costs to sustain. And yet at the end of every shift, they spend 40 people hours moving data from these disparate systems into Tableau into Power BI into some other reporting environment to do a shift handoff meeting for production, for maintenance, and for quality. This is, despite 12 years of Industry 4.0, we're still propagating this cost and complexity. This is what we call unbridled innovation, where every one of these boxes is its own stovepipe architecture, its own data silo, represents vendor lock-in, and we're still propagating this complexity today. This is what has to go away as we think about the future. So in our work together with our 170 some members across this ecosystem, we did the work to define a smart manufacturing specification that sort of rips apart the traditional monolithic application environment. We've created a specification at each one of those layers and put that back into the marketplace as an open specification for anyone to leverage and develop against. But we've also been investing in the technologies to exemplify what this actually looks like. And so we talked about the cloud library that we worked on together with the OPC Foundation in a great initiative. You see the manufacturing information model repository. Well, that has manifested itself as a smart manufacturing marketplace at marketplace.sesme.net. The information models that you see there that define every layer and the key characteristics of this smart manufacturing stack, those are the information models that the OPC Foundation and VDMA and SESME have been investing in and are trying to bring to life through our investments. And that sort of three-tiered box that you see on the left-hand side, we have gone to the marketplace to assemble what we believe the best-in-class example or instance of these capabilities, and we're bringing these to the marketplace through our funding here at SESME. And of course, our goal is to then have the entire ecosystem building applications against an open interface instead of using these information models that we're defining here, instead of against the stovepipe architecture, hardwired sort of data models that these historic legacy applications are leveraging today. So from our perspective, actually, let me just go back briefly. This is an example of what the OPC Foundation and VDMA and these great organizations are leveraging, are building to build essentially de facto standard information models as base types, as class definitions for a modern open interface to develop against. And these are the pieces that we are excited to bring to life through our efforts here. So as you just heard from both Stefan and Mike Clark, we're excited to engage in and invest in these important interoperability-centric initiatives. From our standpoint, we want to enable these types of consensus-driven, essentially standards-based initiatives to build great, robust, powerful information models that can be consumed and instantiated and composed by virtually any manufacturer, small, medium, and large, and be used as a templatized, reproducible interface against which you can develop. And so as part of that, we were honored to be invited to co-lead together with the OPC Foundation and VDMA these important initiatives that clearly align around our core objectives around sustainable manufacturing, right? What we're talking about here in terms of the democratization of smart manufacturing, in many ways, is in perfect alignment with sustainable manufacturing. We in fact collectively need to be able to do a better job articulating the value that we produce, right? When we create a more robust and resilient supply chain, when we drive operational efficiency, when we reduce waste or create a more reliable yield for a manufacturer, those are direct impacts on your company's ESG reporting and metrics that you report to your organization. And so we have to collectively, I think, this is a bit of an aside, get better at aligning the outcomes that we strive for and execute towards and work on every day to our company's sustainable and ESG initiatives broadly. So this is I guess the Smart Manufacturing Institute's lens on how we get this ecosystem to advance in this area, in this direction. We've got the sort of $140 million that SESME is bringing to bear on getting this flywheel turning. The subject matter experts that we're able to invite into this ecosystem to take what they know about a paper converting machine, about a labeler, a cartoner, a furnace, a crack tower, a packaging line, and turn that subject matter expertise into a reusable, portable information model, and bring that to the marketplace through our smart manufacturing marketplace, the OPC Foundation, VDMA, MT Connect on the machine tool side. And then we've funded quite a number. We've funded a short list, but a growing list of important organizations that have great information modeling capabilities with a bidirectional translation that allows me in a PTC thing template environment to carve out a great information model for a process or an asset, carve it out and put it into the marketplace, or to go directly to the marketplace, grab that paper converting machine information model and ingest it inside PTC. And of course, the interoperability that, first of all, you're saving the work, you're building against a standards-based model, and now you're enabling the discoverability of that information model at the application level and can do much, much more, I think, compelling, interoperable-centric work from that point. So that's what we're investing in, to take these really important ideas from the OPC Foundation, the information models, the interoperability that we're all aiming for, and kind of bring that to life. Thanks for the opportunity.
All right. First, I want to start off. My name is Dan Isaacs. I'm a CTO for the Digital Twin Consortium, but I'm also the Chief Strategic Officer for our object management group. And I am between you and the drink, so I will keep this brief. Really, we've heard a lot of different presentations over these last couple days around sustainability, interoperability, digital twin, and what really is it? And one of the first things we did as a consortium is really identified what are those foundational elements in terms of a digital twin. And if you see here, you can see really it's a virtualization of a physical entity and or process. Think about supply chain management, operational resiliency, these types of things. But the key element coming back, and I think this again explains where we are now in terms of what we're looking at for being able to synchronize the data so that you have at a given frequency, often called the twinning rate, so that you have an understanding in terms of what the fidelity, what the accuracy and precision is to ensure you have that between your physical entity or process with that virtualization. Those are foundational elements of a digital twin. Digital twin is a twin of something. If you just have a simulation model, that's a simulation model with an intent to twin. Or as Dr. Greaves says, the founder or the father of, he doesn't like me calling him the grandfather, of digital twin and the concept is really that fact that you have this virtualization, you have your simulation model. If you don't have your physical, that's a design or a digital twin prototype with the intent to twin. So going at that, you can see here, we have, this is actual live telemetry data captured at that time. So this is a wind farm based in Europe. And you can see the telemetry data that's captured. You can see the virtualization. You can see the synchronization. But then you also have the ability now to operate from that understanding, from the analytics that you get from that data, the actionable insight, to now operate and condition on the actual physical. So you really have a closed loop here. That digital twin is providing you a crystal ball in terms of being able to predict based on historical data, based on the situational awareness, the event intelligence happening in quote unquote real time, to then be able to, with the highest level of confidence, because of this holistic view, being able to determine and predict and forecast that optimal outcome. So, as I said, we're Digital Twin Consortium is part of the OMG, the Object Management umbrella. Started about 35 years ago as a standards organization and built out things like SysML, UML, these different types of, and continues to build out through its 200 plus membership. Under that umbrella, realized it was very efficient and effective at building consortia There are 7 consortia now under this OMG umbrella. And if you look at these elements, you can see how there is a unifying theme here. That unifying theme really is around sustainable digital transformation. You can see from where you're capturing the data from the sensors through industry IoT and all the elements associated with that, to then be able to visualize that, and that's through the Augmented Reality Enterprise Alliance, to then bridge that virtualization to the physical through the Digital Twin Consortium. Other areas, other consortia there, in terms of one of the most recent, is around responsible compute. How do you do that in a sustainable and responsible way? That brings in the ESG aspects, it brings in circular economy, those different areas. So what are we really focused on? And you've heard it today, it's the interoperability. How do we ensure the flow of that data through these system of systems, through these complex areas? You've seen examples of that throughout these last couple of days. And we're not just about introducing and bringing out that awareness, but we're really about accelerating the adoption and demonstrating that through real-world applications and values. We have 24 different liaisons, of which SESME is one of those, of which OPC Foundation, as what we're here today to announce, is Digital Twin Consortium is now forming officially a liaison with the OPC Foundation. We have a global membership. We have over 30 countries represented. And we started with 4 different working groups around manufacturing, aerospace, and defense, including natural resources, oil and gas, mining, but also alternatives and renewables, as well as infrastructure, scaling from smart buildings to smart cities. That's what those original 4 stars are. This is a member-driven organization. As we've grown from our original 55 members to over 200 today, which includes researchers, it includes the innovators, it includes the providers, it includes the end users, local government. This is really member-driven, and this growth from these 4 original working groups has been all because of the members that have been joining and saying this is an area we need to focus on, we want to bring together in terms of collective intelligence. So we have a horizontal working group looking at things like sustainability, looking at things like security, trustworthiness, resiliency, privacy, safety, functional safety. And we have cross-working group initiatives. You've heard and seen all around areas in terms of what does it look like from sustainability, that interoperability, and even how does that apply out and manifest itself in terms of the industrial metaverse. We have an open source collaboration community. We have members providing, we also have projects. We have a technical advisory committee to review these projects so that now we can bring in from the outside, you can actually go to our website and submit a project, and that'll be reviewed and brought forward. We also have a technology showcase. I was talking about not just accelerating the adoption, but also demonstrating that value through real-world applications. We now have 5 of these out there, and these are significant and substantive. Buildings as batteries, being able to use alternative resources to generate the energy for being able to do load balancing, active management of the digital twin. Also looking at it from a standpoint of high-speed industrial automation, using virtual reality to control a cobot and those different applications. Another one that was just featured at Barcelona IoT Solution World Congress was showing that and demonstrating that using virtual reality to be able to control that cobot, and this is over 5G. But really what we're here about today is to talk about the strength that we're recognizing by combining and working and developing this liaison with the OPC Foundation. You can see many different consortia that you saw from the liaison. We're bringing these together. And the carbon reporting, we've been working together with some of our members, aligned with SESME, aligned with Industrial Digital Twin Association, aligned with OPC Foundation. We're talking about the harmonization. You heard Jeff talking about that in his presentation. So the harmonization across these different areas, the secure and being able to have that timely determination for being able to, for these timely communications between these systems. And to enable the proliferation across and leverage digital twins throughout these different areas, these applications, and tie them in with what the great work that's coming out of SESME and OPC Foundation. And you've already seen about the Carbon Reporter demonstrator, so one of our members actually has been supporting that as well, and we'll be talking about that further. You'll actually see that released as one of our use cases as part of our technology showcase, which is a reference library of use cases and case studies, demonstrating the value of the digital twin at the different phases of its life cycle. So now this is just a sneak preview, as Michael was showing a little bit too. First results of this are actually already available on our open source collaboration community. I encourage you, if you haven't gone to the Digital Twin Consortium site, if you haven't seen it, take a look at all the different activities that are going on. I think you'll be really surprised at the breadth, the depth, the level of expertise and experience that our members, our relationships through our liaisons, as well as through the different regions that we represent. So it really does take a village. You've been hearing about this over and over, about this ecosystem. We continue to develop and grow that ecosystem out. And we're really excited about going forward into the future. We have major oil and gas companies that are joining. We have 4 airports already. We have end users across the board, as well as a very strong academia and research working group that is building out across the globe, honestly, through this collaboration. And that's what this is all about. It's about bringing the collective intelligence together to collaborate and develop and build these out.
Thank you. So, ladies and gentlemen, we're very grateful that you've stuck it out with us today. This is the last session of Wednesday, and it's been our privilege to be able to share that information with you today. We've got a few minutes before we dismiss. We've got an opportunity for Q&A. We've got our experts still in the room here. I'll moderate. If you guys have any questions, we'd be delighted to hear them. This gentleman over here has a roving microphone, so if you have a question, please put your hand up so that it's actually recorded. We'd like to hear your question on the tape. So, any questions from the audience, please?
Yeah, that's what I believe.
Yep, Mr. Bartusiak in the corner there, just at the back. Thanks.
It's not a question, it's really a comment. So Dan, I'm really pleased to hear your definition of digital twin that requires calibration to the asset that you're modeled. There's been such confusion and uncertainty on this point, and to hear you state that so definitively, because that's the only way these things are going to be of any useful value. So thank you very much.
Thank you, Don. Any other questions? Something I wanted to share with each of you, and that is that the demo unit that we have in the hallway here, you've seen several references to it during our presentations today. That demo unit has to be stricken very soon, so we've got a few more minutes before it has to be taken down. If you've got any questions about that or you want to visit that before we have to crate that up, that would be our privilege to have you come out and share a few minutes with us there. Stefan, did you have any closing remarks that you'd like to share before we call it?
I just like to thank everybody for his time being here, and you have really the unique opportunity to ask any deepest question, because also the CTO of the OPC Foundation, Jim Luce, is here with us. So take this opportunity, right? Right. Okay. Other than that, thank you, Mike, for preparation here. And enjoy the demo and enjoy the later evening, right? Thank you.
Thanks, everyone. Appreciate you.